And we know like okay, you can consider this one as a matrix. This one. Okay, and then this one will be determinant of EK times determinant of EK minus 1 A, right? Right? You can get this one to here. Okay, and then the rest of the terms are here. And then using the similar idea, okay, you can get a second term out and leave the rest here. So eventually, this thing will be determinant of EK times determinant of EK minus 1 times the determinant of E1 times determinant of A. Right? Right?这是这一串嘛，这一串粽子，你一次拿一项出来，一次拿一项出来，就是把它分开成两项相乘，那到最后是变这样子。As I say, okay, some of those elementary matrices, their determinant are not necessarily one. Not necessarily one. So the multiplication, we don't know the multiplication of these values. We don't know. But one thing we know for sure is that these determinants, their values are not zero, right? Their values are not zero. This is, we know that for sure. We check all these three elementary matrices. Okay? The first one gives us -1. The second one gives us C. That C is non-zero, by the way. The third one gives us 1. Right? So all these three, okay, their determinants are non-zero. So if all these are non-zero, the left side is 1. Let me ask you this. Okay, the determinant of A will not be 0, right? It cannot be 0. Right? It cannot be 0. So this is important. It means what? If a matrix is non-singular, its determinant is non-zero, and because this is like if and only, so vice versa. So if a determinant is singular, it means what? It means its determinant must be 0. Okay? And this is also very, very easy to understand, because if a determinant, if a matrix is singular, what does that mean? Actually, like if you apply a series of raw operations on a singular matrix, by doing like by converting it to row echelon form, okay, eventually you are going to get some rows completely 0 at the bottom, right? At least one of them. At least one of the rows to be completely 0. Right? So in other words, like all this multiplication times on the left hand side, it's not going to be identical. It's going to be one row to be 0, to be all 0. So if you have one row to be all 0, the determinant is 0. We discussed that already, right? Right? 如果你的 matrix 那个一列是全部是0，它的 determinant 是不是0？ 对，前面有讨论过这个，对不对？对不对？我们知道说，如果是 singular， 你用那个 elementary row operation 到最后得到的是，你至少有一列是零，对不对？对不对？所以类似像这样哦，比如左边就不是 identity matrix， 左边就是那个有一列是零，它的 determinant 是零，对不对？右边就是那些 elementary row elementary matrix 的 determinant 乘上你那个matrix 的 determinant， 那这些乘起来是零。那我问你，这些 elementary matrix 的 determinant 都不可能是零，所以唯一的可能是那个 matrix 的 determinant 是零，对不对？对不对？所以 OK， either you try to understand this from here, or you try to understand this one from my explanation. Okay, so we know like okay, the matrix is singular. It can only determinant of this matrix. This is very important. Okay. Okay, so let's take 10 minutes break. I will go back to my office and see if I can fix my